All right, what do you say? Here we go. Number 11, I got a regular hexagon. All sides are the same. What degree measure will carry the hexagon onto itself? Meaning, how many degrees can I rotate this hexagon? So, where'd it go? So I can get the same hexagon back. How many degrees did I just rotate and get that hexagon back? Basically, what I'm asking you guys is, how many degrees do I go from one vertex to the other? How many degrees do I end up going? All right, that's what I need to figure out. If I go all the way around, how many degrees am I going? I'm definitely going to get that figure back. And what would it be? 360, right? But that's probably never going to be a choice. So yeah, I could go 360 all the way around, but how many turns is it taking me to get to all the way around to 360? How many turns? 6 vertices, right? Turn to each vertex 6. So every time I go 60 degrees, you're going to get that same hexagon back. Problem though? Not a choice, right? Not a choice. Remember what we just said. Every time you go 60 degrees. So I could go 60, not there. You could go another 60, and how many degrees am I at now? 3? 120. And guess what? If 120 wasn't a choice, I keep adding 60 until I see it. All right? So 360 divided by the number of vertices gives you a minimum amount of degrees, but again, you can go 60 every time. Hooray, we're going to need some studs here for number 13. Skip over to 13 here. We're going to need some studs to remember a formula. See if I got any in the house here. Circle question. Area of a sector. Ooh, area of a sector. I don't want to call on anybody because you probably don't know it off the top here, but anybody remember the area of a sector formula? Romeo?
An angle measure over 60 times pi r squared.
Measure over 360, yes indeed, times pi r squared. All right. So let's go to the diagram now. BE is 9. What's 9 again? BE is a what? What's BE? Radius. All right, so I got R. That's perfect. TRE, this angle right here, 15 degrees. Anybody remember what type of angle that is from your circle days? Inscribed. How do you find it? Half, right? So if that's 15, what's TE? Everyone good? That's 30. But, be careful. I'm not plugging in 30, though. Look at the sector I'm asking you to find the area of. Sector EBR. All right, EBR. So what I need to plug in for the measure is angle EBR. Can you get to that angle for me so I can plug it into my formula? EBR. Anybody think they can get there? Carter.
TVE is like 30 because it's the central angle.
Good job. Carter's like, hey, TBE, this angle right here is 30. Central angle equal to its arc. Keep talking.
So, and RVT is the diameter, so it's like straight line, and it's 180 degrees. So
Yep.
RV.
Good. These two angles are supplementary. That's 30. This is 150. Or did anybody do, if that's 30, this arc's 150 because that's a diameter, and then the central angle is 150. All right. Good job. Good job. There's still one piece here. This is why this Regents is so tough. We just did a heck of a lot right there, and that's still not even good enough. 150 over 360 times pi 9 squared. Look at all your choices. What are they? In terms of pi, right? So don't press the pi button on the calculator. Leave it there. Multiply 150 over 360 times 9 squared. And I'll get back to you in a minute. When you're ready, what are we getting with the pi there? Oh, 13. Looks good to me, Lucy. Good. 33.75. Oh, boy. Anything on the old circle? And I am going to give you guys, I don't want to give it to you now because it's going to be too overwhelming because we're still doing the volume unit. But once we're done with volume and we just study the whole time on the Regents exam, I'm going to give you guys a packet that's got all the facts in it, including area of a sector. All right, so that'll be in that packet when the time comes. I just don't want to hand it to you now and overwhelm you. I got a couple more still. We got a slow day today, so 16. RV 4.1, TV 10.2. What's the length of ST to the nearest 10? There is a phrase in the directions I want you to be familiar with. Ready? Altitude to the hypotenuse. Altitude to the hypotenuse will always tell you what type of problem this is. Altitude to the hypotenuse is always a Hills SAS question. Remember those days?
Good times.
So if I see if I see altitude to the hypotenuse, Hills and SAS. Ooh, which one does this involve? Because I got to pick one, right? I got to pick which one I need. What's the altitude in this diagram? What? It's labeled up there for you. Altitude. Is it have anything to do with what I'm trying to find? So guess which one it's not going to be? SAS, right? So instead we're going to use Hills. All right, buckle up. May need your calculator here. Let's first hear from 5. Jackson, you remember what the H in Hills stood for? Okay, and it's the hypotenuse of the big right triangle. The hypotenuse of the big right triangle. Can you find out how long it is for me? The hypotenuse of the big right triangle, RST. How long is it? Got to add a couple of numbers up for me. Hypotenuse RT. That's the one I'm looking for. Hypotenuse RT. How long is it? Yep. 14.3. Everybody good? H stands for the hypotenuse in the big one. Everyone ready? What's the L? The L. Something we're not taking on this exam. 10. What's the L, Josh? Leg. Now you got 2 legs, literally and in this diagram. The legs are the legs of the original right triangle. Which is the one we're dealing with? STX. Leg again, same one or different? Same. Here's where you make your money here. What's that S stand for? Anybody remember what that S stood for in Hills? 13?
Segment next to the leg.
Look at you. I didn't even have to ask. There you go. Segment next to the leg we're using. So can you give me that segment too? Finish that off.
10.2.
Darn right. 10.2. Okay, there it is. Cross multiply. Take the square root and we're on our way. To the nearest tenth, let me know. 15. 12.1. Questions? Hills and SAS, altitude to the hypotenuse. Ding, ding, ding. Hey, 28, one more problem. Let's do a part 2 problem. See if anybody remembers from our circle days here. 28. Whew. secant and a tangent. The lengths of secants and tangent. Anybody remember the saying I gave for this one? How to find the lengths of tangents or secants. I had a saying for it. Any takers here? Any takers yet? Luke.
Isn't the whole times the interior
Ooh.
exterior?
External, yes. Whole times external equals whole times external. Yep. All right, now I can start calling on you guys. Here we go. 4, what's the whole secant length?
She's not.
Okay, thank you. Just going to stand here. 19, whole secant length? 12.5. Be careful. External. Don't give me 4.5. External part of that secant. 12, external part?
She's also not.
5, what's the external part there, Jackson? 8, good. 12.5 minus 4.5. And then what I can say about the whole and external tangent, x times x. So x squared equals, oh, look at that number, huh? 100. X equals 10. Ooh, Hill SAS, whole times external, all in one review. Good. Any questions? Okay, put it away. Sphere. Last figure we got to talk about. Sphere.
How are we doing over there, boss?
Great. Good. You gonna be ready for these finals? Okay. You don't get an 80 or what on this, then we produce 20. No pressure, but just saying. All right, sphere. We have yet to talk about a sphere. The only thing you need to know about a measurement, the only measurement you need to know about a sphere is this one right here. From the center to a point on the sphere. Wild guess what that measurement's called. Radius, yes. That's the only thing you need to figure out about a sphere is what its radius is. So the first thing we'll talk about is what's the surface area of a sphere. Unfortunately, bad news, that's the only formula from this section that will not be given because it's not a volume. It is surface area. So ready? 4 pi r squared. There's your surface area formula. All right, 4 pi r squared. Done. So again, what's the only measurement you need to figure it out? 4 is done, pi is done. I need to know the radius of the sphere, and I get the surface area. All right, let's try it out. Not a basic problem at all. I'll give you the circumference. What's the surface area? So what'd you guys just tell me? You need the what for the surface area? What's the only measurement you need? Radius. Can I get that from the circumference? Do we remember the circumference formula? If not, it is on the formula sheet if you want to take a peek. It is on the formula sheet if you forgot. Pi d, yep. Circumference equals. Wait. You guys just told me seconds ago you needed the radius, though.
Yeah, so just divide by 2.
What by 2?
You know the diameter.
Oh, find the diameter and divide it by 2. All right, I got it. So the circumference, 20 pi. Let's plug it in for C. Equals pi d. All right, somebody get me the diameter there. Ho, 3. 20, pi's cancel out. D equals 20, so my radius. 10. All good? And now can we find the surface area? And I'm going to make it easy on you guys because I just grilled you with a lot of regions questions. Leave it in terms of pi. Leave your surface area here in terms of pi. 10 squared. Five. Jackson, what do you got in terms of pi? What pi? So multiply all your numbers but the pi. 400. And we're back. Hey, we're back to surface area. So what am I attaching to this now? Centimeters squared. Good, good, good. All right, so 4 pi r squared for the surface area of a sphere. What about volume? It is involved, but luckily you have your formula sheet. Go ahead, dig it up for me. It's no joke, but thank God you have it in front of you. When you're ready, 13, when you're ready, surface area of a sphere.
4/3
Woo!
pi
4/3
r
and cubed. Are you kidding me? I know what's coming up, so I need to get my calculator out here. All right, here we go. I'll give you the volume of the sphere. What's the surface area? Again, what's the only value I need? Radius. Okay, so can we get that from the volume? Volume, 4/3 pi r cubed. The volume's 36 pi. Plug it in for the volume. And we need to figure out what the radius is now. All right, can we do it now instead of waiting? What's going to cancel? Yep, pi's are going to be gone. So 36 equals 4/3 r cubed. What's your next move, algebra studs? Because you got to get rid of that 4/3 before you do anything. 11, next move.
Multiply each side by 3/4.
Woo, reciprocal. 3/4. 3/4. So on the right, you got r cubed. And on the left, you got 27. All right, I don't think we've talked about this in this class, what to do next.
I think you did.
Have we?
Yeah, you gotta use the little math.
I wonder when we talked about it. If there was a 2, I'd square root it, but there's a 3, so I do what's called cube rooting it. And did I discuss where it is on the calc? Under math. Yeah, under math, hit your math button, and you should see it there, choice 4, cube root. So your radius is 3. Now use it to find the surface area in terms of pi for me. 4 pi r squared. Surface area in terms of pi. 11 again. 36 pi square inches. Oh, it came out to be the same. It's not the same as the volume. Remember, volume is inside, surface area is outside. Okay, surface area is outside. So we're okay taking the cube root? That was the point of that question, making sure we could take the cube root at the end. Regents question coming up. Old Regents question right here about the old volleyballs. So you got 2 types of volleyballs. You have one volleyball that's partially inflated. You can call it whatever you want, PI. And then I have a volleyball that is fully inflated. You know the volumes of each. What I want to know is how much did the radius increase by from the partial to the fully? I'll get you started because something's going to happen here that has yet to happen to us. So let me do the partially inflated with you. The volume is 180. This is the first time it happened. What does the left side not have? A pi. So can I just cross off the pi and go? No. You have to have pi's on both sides, so it's not gone. You need to get rid of it. So if you want to get rid of it, let's say you want to get rid of it right now, how could you get rid of it? Divide each side by pi. Correct. And do not round any decimals. So go ahead right now. Find the radius of the partially inflated. Find the radius of the fully inflated, and we'll talk about how much it increased by. Go ahead. So just check your radii up here with me. Okay, check your radii up here with me for the fully and the partial. Everyone all right? The radii matching up with you? And now I want to see how much it increased by. All right, I just need one person to let me know, how do you figure out how much it increased by? I got these two here. I got 4 operations: add, subtract, multiply, divide. How do I figure out how much it's going to increase by? One, George.
Subtract the fully inflated to the partial.
Great job. You got that number for me?
Oh no.
Do your thing. Spotlight's on you, but I know you can handle it. Big players step up in big games.
0.6. Yeah, 0.6.
Yeah, 0.6. Good work. Inches. Questions from you guys before we get to this last one? All right, take a sphere, slice it in half. You have what's called a hemisphere. There it is. I want to find the surface area and volume of this. All right, surface area and volume. Let me start with surface area because it's not as easy as slicing it in half. So ready? Surface area of a full sphere was what? From today's class, surface area of a full sphere. 7?
4 times 5.
Right? That was a full one. But this is a half one, so I know a lot of you are going to say, you got to take that and cut it in half, which you are correct, but you're missing something still. All right, you're missing something. When we did that whole entire 4 or 5 days on surface area and had a quiz on it, what's the definition of surface area? Everything on the outside of a figure, right? Outside? Well, dividing it by 2, you're only covering like the dome part. I flip it up. What's still on the outside that we haven't covered? The bottom, which is in what shape? A circle. And that is not covered here. So what we need to do is, yes, divide it by 2, but also add in the bottom of the hemisphere. What do you think I'm going to add in for the area of the bottom? It's a circle, so it would be pi r squared. So surface area of a hemisphere, I got to worry about the bottom part, covering the bottom part, which is a circle. If anybody wants to change this into 2 pi r squared, that's fine before you start. What are you plugging in for the radius here? Radius 2, radius 14, thank you. And they give us rounding directions, nearest tenth, yep. Three. What do you got for the surface area?
1,147.2.
Great job. Any issues finding that? Volume. Ready? What's the volume formula from today? Formula sheet, whatever. 6, volume formula.
4/3 pi r.
This is a hemisphere though, right? So I am going to have to cut this in half. You could, I don't know if you like doing that, that's fine. If you don't like dividing by 2, what could I also multiply by? A half. And you don't have to worry about the circle on the bottom because what's volume? Everything inside. So I don't care about the circle on the bottom. But you do have to cut it in half though. Okay, you do have to cut the volume in half. Four, when you are ready. You're going to tell me that quicker, or I'm not going to remember this stuff. 18?
5,747.
Yep. PQ. Okay, so again, surface area, add in that circle, volume of hemisphere, just cut it in half. Get going on the assignment. Get going. There's not that. What do I got? 1, 2, 3. Good. Nice. Man down.